Hello, welcome to this video on tutorial for basic electronics. Here we will be discussing the very basic concepts of electronics section involved in our projects to understand the working and hence understand the entire circuitry. So now let us move on to the first section, that is the power supply or the battery. As you can see, this is a single cell having polarity as minus and plus, and this is a multi-cell arrangement that can be also called as a battery, which is having multiple negative and positives connected in series. So this is how a battery is symbolized, that is from the negative to positive a battery is connected to the negative of the other one. That means the positive of a battery of a cell is again connected to a negative of the another cell, and similarly these are connected, other cells are also connected. Now a series connection here actually means additive of the voltages. That means if this single cell is suppose 5 volt and we have connected 3 of them in series, so we can get 15 volts. So this is how the battery works. Now let us move on to our next thing, that is voltage and current. What the battery supplies is actually voltage and current, and these are the various symbols for the voltage source. Suppose we have a DC source, then the symbol for the DC source is given as this, with a plus and minus symbol. Now suppose this is a 5 volt DC power supply, so between these terminals of plus and minus we will have 5 volt power DC supply flowing if a load is connected, and this is the symbol of an AC signal. That is, if a load is connected between these two terminals of this device, 120 volt AC voltage will flow through the device, and this symbol here is of current. Suppose we have an ammeter connected in series with our arrangement, then this symbol will actually be used wherever we are measuring the current in the circuitry. The relation between voltage and current will be shortly discussed. Let us move on to the next section, that are resistors. Now resistors come in various values, and these values are actually standard, varying from say basic 10 ohms or 2 ohms, 22 ohms or 220 ohms or 330 ohms, and similarly there are some standard values for which commercially resistors are available. Now how to recognize a particular value of a resistor? For this, the standard method that is used is a color coding method. The color in this color coding method we have various color bands depicting various values of the significant digits in the numerical value of the resistor, and also the tolerance band. So let us see how a particular resistor value is calculated. Suppose we are having this resistor, so here we have a red as the first digit, so it's 2. Then we have green as the second digit, green is 5, so it's 25, and the third one is actually orange, and the orange is actually 3, so it is 10 raised to 3. The last number happens to be the power of 10, so we have 5 into 10 raised to 3 kilo ohm. So this resistor is 25 kilo ohm, and the tolerance band is in golden color. For gold we have as 5% tolerance, so this resistor is a 25 kilo ohm with a tolerance band of 5%. A tolerance actually means that the resistor value may vary between plus 5% to minus 5% of 25 kilo ohm. So this is how a resistor value is calculated using the color band. Similarly, the resistance of a resistor can be calculated with the help of a multimeter also, by connecting its leads between the terminals of the resistor and putting the multimeter in resistor mode. So this is how the resistance of a resistor is measured. Now let us move on to the next section, that is our basic principle of knowing the relationship between a voltage, current and a resistor, that is the Ohm's law. Now what is Ohm's law? It is actually expressed in terms of this equation, which is V is equals to IR, where V is the voltage in volts, I is the current in amperes, R is the resistance in ohms. So whenever we are given two quantities, we can find the third one using this relation. So now let us actually see a simulation of the relationship of voltage, current and the resistor. So here we have a simulation of the phenomena of Ohm's law, and let us see how it actually works. So here we have a 5 volt power supply. As we can see, we have two resistors, one is 100 ohm and one is 1 kilo ohm. So depending upon the resistor value and the potential across them, the current can be calculated using the Ohm's law, that is V is equals to IR, as the other terminals being grounded and the one terminal being connected to 5 volt, the the current through the resistors can be easily calculated with the Ohm's law equation. So as we have a 5 volt and a resistor of 100 ohm, so current can be calculated as 5 by 100, that is 50 milliampere, as shown over here. So in this branch we have 50 milliampere of current flowing. Similarly, now let us calculate for the other branch. Here we have a 1 kilo ohm resistor and 5 volt power supply. So the current flowing through this branch is 5 divided by 1k, that means 5 milliampere, that is 5 into 10 raised to minus 3 amperes. So depending upon the resistor value, the current will flow with according to the Ohm's law equation. What we note over here, that the higher the value of the resistor, the lesser the amount of current flows through it. So this was the simulation of Ohm's law circuit, in which we saw the relationship between voltage, current and resistance. Now let us move on to the next section, that is switches. Now in switches we have various kinds of switches that can be used according to the scenario that we want to connect it into. For example, we have this one, that is single pole single throw switch. Then we have single pole double throw switch and double pole double throw switch. And similarly we have many other kinds of such switches that can be used according to the need. For example, we want an input to be connected to another port where we want it to be connected. So we can use this switch, where whenever desired, this key is closed and we have a closed circuitry over here, that is a connection that is made. So make and break connection can be done using this one. This switch we can simply press and the connection is made, and by releasing we can break the circuit. That means this is a more like push button type of switch. Here we have a switch that can connect to two other ports. So if we want the input to be given to this section, we can like connect this over here as a closed switch, and either way we can connect this switch towards this so that this connection will be made and this pin will be open. Now similarly we have double pull double throw, where by a single press we can make and break two connections at a time. Now these switches are not used as a standalone but used with a capacitor, and the reason being for it is debouncing. Let us see what is debouncing. Whenever a switch is actuated, that means whenever a switch is pressed, suppose that when the switch is pressed it will give a high signal. So in this situation, when a switch is actuated, that is it is pressed, you can see these spikes. These are actually recorded from an oscilloscope, and we are displaying a close-up view of it. So you can see that there are very sharp spikes before it goes fully stable to a stable high. So before a stable high there are multiple oscillations of the switch, and the reason for it being debouncing of the switch. So what to avoid this condition of debouncing, we use a capacitor with the switch in parallel with it, so that it suppresses the debouncing conditions. Now let us move to the next section, that is the potential divider. Potential divider or the voltage divider circuitry actually divides the voltage into certain ratios of what we want. And how to do this, we can see over here. We have two resistors, R1 which is connected to the supply. Suppose we have a supply and this is connected to R1, and then R1 is connected to R2 and R2 is connected to ground. So what we get over between R1 and R2 is the divided potential. And how to calculate this potential is very easy. We can use this simple formula, that is U2, that is the potential across R2, is equal to U1, that is the potential across R1 and ground, into the resistance we are measuring across, that is R2, upon the addition of both the resistors, that is R1 and R2. So the formula comes as U2 is equals to U1 into R2 upon R1 plus R2. So in this way we can actually divide the voltage into whatever ratio we want. So now let us see a simulation of how this actually happens. So this is the simulation of potential divider circuit. Now let us see how the potential divider circuit is working. We have this potential, that is a voltage source, as 10 volt, and let us calculate for this terminal. We have 10k here and 10k here. So by the potential divider theorem, we have the voltage as 10 into 10 divided by 10 plus 10, that means this and this. So we have 10 into 1 by 2, that is 5 volt. So by the potential divider we got that it is 5 volt here, and we have also written in the simulation that it's 5 volt over here. So now let us move on to a bit more complicated circuit, that is this one, and let us calculate the voltage over here, this point. Actually this is not that complicated as it seems. What we have to only do is add up these three resistors and make them one, because they are in series connection, and the other one which is connected to the ground. So we have again the potential divider circuitry, the standard one that we had seen earlier. So we can calculate it as voltage, that is over here, that is 10 into the resistor, that is 10k, divided by 10 plus all these 3, that means 30, that means 40k. So what we get over here is 10 divided by 4, that is 2.5 volts. So what we get is actually correct. So this was how the potential divider circuit works. Now let us move on to the next section. So just now what we saw was the simulation of the potential divider circuit. Now let us move on to the next section, that is the trim pot. Now trim pots are actually based on our potential divider. How they work is that one terminal of them is connected to the power supply, the third terminal is connected to ground, and the variable terminal where we want variable voltage is to be connected to the second pin. So that means on the second pin, by varying the position, we can get various voltages from 0 to the maximum value that we can get, that we have on pin number 1. As depicted in the figure, whenever the potential divider, that is the trim pot, is rotated clockwise, the wiper moves in this direction and it approaches this voltage, that is on pin number 3. Whenever the potentiometer is wounded counterclockwise, it approaches this terminal and we have the voltage approaching to the voltage at pin number 1. Now let us see a simulation of how a potentiometer works. So this is the simulation of the potentiometer. We can see an arrangement of two power supplies being connected with the potentiometer, and the potentiometer is in equilibrium position. That means the wiper is in the middle of both the terminals. So what this means is actually the potential will be divided equally to both the branches. That means we will have equal currents flowing in both the branches if we have equal voltages at both the branches. Suppose we have 5 volt in this branch and also 5 volt in this branch. So we can observe that the current that is shown over here will be like 10 milliampere, and in the second branch also we will have 10 milliampere, as the potential divider is dividing the voltages into half in both of the branches. So this was how a potentiometer is working. Now let us move on to our next section. So just now we saw the simulation of a trim pot. Now let us move on to our next section, that is a resistor array. So a resistor array is now again similar to the potential divider and works on the basic principle of a potential divider theorem. What we have over here is a common terminal to which the power supply is given, and in return these are divided to various branches having the same value of resistance. For example, if it's a 330 ohm resistor array, we will have 330 ohms connected to each of the LEDs, so that we can get actually the same resistance in all of the LEDs. Now actually where these are used, resistor arrays are used basically for as a pull-up in various scenarios where the microcontroller cannot source the amount of current the device actually needs. So in that scenario we will be connecting, for example, a 10k array in which all the resistor values will be 10k and the common supply will be given to 5 volt. So in such situations the signal power is boosted with the help of the resistor array, and thus we can get proper signals to be detected by the microcontroller. So now let us move to our next section, that is transistors. Now there are two types of transistors. One is the NPN transistor, while the other being PNP transistor. These are the basic symbols of them. In the NPN transistor, we have a P layer sandwiched between two N layers, while on the contrary, in the PNP transistor, we have an N layer sandwiched between two p layers. Now, for what reasons are these transistors used in our circuit? Transistors are used for amplification and as well as for as switches. For digital circuits, mostly we'll be using them as switches. That is, we will be operating these transistors in their saturation region. Now let us see the simulation of how this works, how the transistors work. Now this is the simulation of an NPN transistor. We have this as the base, this as the emitter, and this is the collector. The collector is connected to a 2-volt supply, which is to be given to the other device, which will be connected either over the collector or over the emitter. The base is connected to 0.7 volt. So what we see over here, that when a 0.7 volt is connected at the base, we have some current flowing through the base emitter, and due to this the switch gets on. That means the collector and the emitter gets shorted and the supply is continuous from the collector to emitter. So this can be operated as a electronic switch, where this terminal can be given to a microcontroller, where we can control the switching on and off. That means giving a logic high, that is close to this 0.7 volt, to on this transistor, and the other one being close to 0. That means this will be off. Suppose I give a lower voltage over here. That means suppose I give 0. So what we see, that the current has ceased to flow and the switch is off now. So this can be operated as an electronic switch with the help of a microcontroller, and the controlling logic can be given by the microcontroller, while the supply that needs to be given to our device, depending upon the controller logic, can be given through the collector or through the emitter. There are various configurations in which this can be done, like the common collector configuration or the emitter follower configuration. So now let us actually see an PNP transistor. Now this is a PNP transistor. In this we have the little symbol change. That means the emitter is shown as going inside. Now the base region is given plus 1.3 volt, due to which the current is flowing from emitter to collector. So this electronic switch, here we can give 1.3 volt through microcontroller, and due to which the emitter or collector current is flowing. Here again, as done before, we can lower this voltage, due to which now again we can lower this voltage to see what happens when a electronic switch is off. Suppose we can down this voltage to 0, and due to this the current ceased to flow from the collector to emitter. That means now the supply given to the load is switched off. So in this way we can have a digitally controlled switch with the help of transistors. This can be used to switch on and off a relay, for example, in our circuits. So this was a simulation of NPN and PNP transistors.